Hello students, welcome back to AriserTalent. I'm your maths teacher Arpita Sharma. Students, we are discussing probability chapter, and in that we have gone through the basic concept of probability, the mathematical concept of probability, and then we have done some good questions. Okay, in that series we are having this question. Let's have a look. Two customers, Abbas and Shaila, are visiting a particular shop. There are two persons. The first person's name is Abbas and the second person's name is Saila. They are visiting a particular shop, okay, in the same week. But the particular days of the weeks are Tuesday to Saturday. That means they are not visiting on Mondays and the Sundays. So Monday, Sunday they are not likely to visit, but there are fair chances that they can visit particular shop in the same week. That's like that will be maybe a date 7 to 7, 8, 9, 10, 11, 12, 13. So 7 to 13, right? Each is equally like to visit the shop on any one day as on another. Okay, what is the probability that both will visit the shop on the same day, different day, consecutive day? So there are three cases basically. So what we have here having three kind of varieties in the same question. So we will consider for the same day, for the different days, and for consecutive days. Okay. So just first we're going to look at what we have given. So the solution is there. Now students, what we are having, total chances or total outcome of what are the possible ways that the Shaila and the Abbas may visit that particular shop in the same week, that is Tuesday to Saturday. So if I'll go with this space pattern, sample space pattern, then I can have this, that we are having Abbas and we are having Shaila. Okay, so Abbas is visiting Tuesday. If Abbas is visiting Tuesday, what are the possible ways for Shaila? So I can just draw a table for that. So if Abbas is visiting on Tuesday, then Shaila can visit on Tuesday, on Wednesday and Thursday and Friday and Saturday, but not Sunday and Monday. Why? Because Sunday and Monday are not allowed. Similarly, Abbas can visit on the Wednesday. In case of Wednesday, again these 5 cases will be there. In case of Thursday, again that 5 cases will be there. Similarly, in the Friday, 5 cases will be there. In the Saturday, the 5 cases will be there. That means in simple words, what I have make you understand in the very first or second question of this chapter, I have told you if there are 5 ways. 5 ways how? Because Abbas can visit Monday, Tuesday, Wednesday, Thursday and Friday. There are no 5 chances, students, there are 6 chances. You should stop me when I am getting wrong. So there are 6 chances, 6 fair chances. There are one more, Saturday. Okay. So there are only, okay, give it a break. What we have misconcepted here, Tuesday to, so if I am going to talk about Abbas, there are 5 ways, okay. So starting from Tuesday, not Monday is not included, Tuesday, Wednesday, Thursday, Friday and Saturday. So there are 5 ways, so this is 5, multiply, because the event can occur simultaneously. So I'm going to, because Abbas and Shaila, if it was a or between them, either Abbas or Shaila, then we will not going to use that plus sign. But in our questions, whenever we are getting and Abbas and Shaila, so that will be 5 multiply by. Now the chances for this is Shaila, again Tuesday, Wednesday, Thursday, Friday and Saturday, that means 5. So what will be the probable outcome, total outcome? That will be simply 5 multiplied by 5 and that will give you 25. So there are 25 ways in which Shaila and Abbas can visit the shop in a particular week. Okay, so understood this? You don't have to write it like this. We'll write this in our own way. Okay, systematic approach. This was the approach that by that you can understand what I'm telling you. So the solution you've given with the thing. Probability of visiting or visit days, I'll write visit days of Abbas equals to Monday, not Monday, Tuesday, Wednesday, Thursday, Friday and Saturday, and that is equals to 5. Okay, now visit days of Shaila, that's the name spelling, right, equals to again Tuesday, Wednesday, Thursday, Friday, Saturday, and which is again 5. Okay, now total probable ways of visiting Abbas and Shaila in no conditions apply, so in given week will be equals to 5 multiplied by 5 equals to 25 and this is equals to NS, total outcome. You can write total outcome. Okay, now this is about the total outcome, students. Now what will I do next? I'll just pick the first case. And the first case is the same day. Probability of visiting the same day. Probability of visiting the same day, we can write it as PA. Okay, so probability of visiting the same day, that means Abbas visiting the store if on Tuesday and Shaila will be visiting the store on Tuesday too. If it's Wednesday for Abbas, it will be Wednesday for Shaila too. If it's Thursday for Abbas, there will be Thursday for Shaila too. Right. Now, that means we can write as like favorable outcome. Favorable outcome are what? Abbas Wednesday and Shaila Wednesday. This is the first situation. Second is Abbas Tuesday and Shaila is on Tuesday. The second one. Then the third one, Abbas Wednesday and Shaila Wednesday. No, Wednesday has been done. So that is Thursday. Then Abbas Friday and Sheila Friday. So Wednesday, Tuesday, Wednesday, Thursday, Friday, and now we go with the Saturday. So Abbas Saturday and Sheila also Saturday. Now any more thing that can have that may be include? No. 1, 2, 3 and 4 and 5, that is equals to n of a, and this is equals to 5. 5 cases: Wednesday, Tuesday, Thursday, Friday, Saturday. You can just write this before this because this is the actual sequence. I have just written it wrongly. Okay, sorry. So this is NA and there is your NS. So you are having NS, you are having NA. So you now just can calculate this value of PA. Implies that PA is equals to NA by NS, and which is equals to NA is 5 here and NS is 25 here. So that will be 1 by 5. That will be your answer. Okay, so note this first part and then we'll move to the second part of the question. Right? Okay. Now students, we are dealing with the second part. And what is the second part? Different days. Now you are having two ways. Event B. You are having two ways, tough way, easy way of solving this. How many different how many ways have been there that can have different days. You are having total number of outcomes and you are having one more thing which is the same day outcome. So if you'll just remove the number of outcomes which were of the thing that they have arrived, they have visited the same day, you have subtracted them from the total number of ways, then what you have remained with? You have remained with the different days. Now have this in that way: different days visit. This is just for understanding. Is equals to different days visit is equals to number of total days, total outcome minus number of same days. Situation. If number of total same days are 5, that means the another 20 days. The another 20 days are the ways actually that may have that will surely not having the same day. If I am not having the same day visit, then they are going to visit on a different days, right? So it's just simply favorable outcome for event B is equals to NS minus NA. Then that is equals to NS was 25, NA was 5, so that will be 20, and that will be your NB also. Now you are having NB, you are having NS, so what are you waiting for? Just put the damn formula and the values and get the answer. Okay, so this implies that PB is equals to not yes PB, okay, equals to NB upon NS, and that will be equals to 20 by 25. Now you can cut that crap, that 4 and 5. So 4 by 5 is what you are looking for as your answer 2. Right? Note it. Noted? So this is your for different days. Now the third is consecutive days. Now consecutive days. Now you know this thing that we are having total number of outcomes, possible ways equals to NS equals to 25. So I am zubbing this complete thing and we'll talk about the third point. Okay, so the third one, and which is consecutive days. Now wait, what is consecutive days mean? Like you're having a bus, you're having Shelam. If a bus give a visit to store to the Tuesday, because Tuesday is what it's the week starting from, in that case Tuesday to Saturday. So if it will be visiting Tuesday, maybe let's suppose it's visiting Tuesday, then the other one can be Wednesday, Thursday, Friday and Saturday. Now students, look carefully. If a bus is visiting on Tuesday, shall I will visit on Wednesday. If it's visiting on Wednesday, shall I visit Thursday? If it's Thursday, shall I visit Friday? If it's Friday, then shall I visit Saturday? If it's Saturday, shall I visit Sunday? No, not Sunday, because Sunday is not allowed. So, shall I will visit the next day, that means the what you call it, Monday. Okay, so Monday is not consecutive day. So, no, this is not done. These are the 4 ways. Similarly, now we will talk about the Shela and Abbas. That was the dependent of Abbas and that is dependent of Shela. Now we will make Shela visit the store. Let's suppose Shela Tuesday or Wednesday or Thursday or Friday or Saturday. Now same thing will occur here and that will be cross for good. Right. So, Shala Tuesday and this is Wednesday. So, now these are the combination. The 4 combination here plus 4 combination here. So, the total combinations are 8. Understanding this? So, total combinations are 8 because if Abbas is visiting on Tuesday, Shala is going to visit in the Wednesday and the vice versa. So, 4 cases here and the again 4 cases here. Noted? So, what will we do? Now, we will be having this as event C, and if this is event C, what you are getting by the table, number of favorable outcome, of visiting the store, or the shop on consecutive days, is equals to 8 number of total possible ways. So, that will be known as your event C. It is so, and C. Okay. Now, probability of occurring that event C will be equals to what? NC upon NS. Now, we have all known about the NS, that is 25, and NC we have calculated 8. So, this 8 by 25 is what will be your answer number 3rd of this question. So, note it so that we can move forward, students. Noted? Okay. So, now next question. In the next question, student, I am having 20 box, not box, but balls. A box containing 20 balls bearing numbers. These are 20, so 1, 2, 3, 4, 5 and the counting will go on the 20. Okay, students. What is the probability or what is the probability of getting if we'll talk about randomly having a ball from that, from that box. Okay, so the first point we are having 3 to 4 points, an odd number. Okay, in the second case you are having divisible by 2 and 2 or 3. The third one is a prime number. And the last one is not divisible by 10. So this is your question, and now you have to deal with that question, and this question is basically so simple, student. A box containing 20 balls. So I am having a box, I am having 20 balls in it. Now these are numbered as 1, 2, 3, 4, 5, 6, 7, 9, 1, 9, 10. That means there is one ball having number 1 and the second ball it's a number 2, 3, 4, 5, 6, 7, 20 till 20. What is the probability of getting? So now you may know by only reading this particular line, these 1 or 2 lines, that the total outcome, the total conditions, the total chances that may be happen will be equals to what? 20. So NS is clearly here 20. NS is what? NS is 20. Now first is of probability of getting an odd number. Now 1 to 20, odd number. It's so simple. Okay, we have covered all the things in number system in the previous classes also, and in the first lecture real number I have talked about the odd numbers also. So students, solution number 1, or I just may write not 1 but total number of chances, total number of balls equals to 20. This implies that total outcome equals to 20, and that will be equals to NS. This is for 1. Now what is first part? An odd number. we'll call it event, what we call it, event A. It's the first one, so we'll call it A, simple. Now, in event A, odd numbers will be what? 1 is odd, 3 is odd, 5, 7, 9, 11, 13, 15, 17, 19. Simply that will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So, 10 are the odd numbers, that is equals to number of favorable outcome. If they are number of favorable outcome, they are in numbers 9 equals to, or you may write NA, which is equals to 9. Okay, so that means probability of getting an odd number ball is equals to NA by NS, and that will be equals to NA is what? That is not 9, that is 10. Okay, numbers are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are 10. So 10 by 20 is equals to 1 by 2. You may say there is half probability of getting that number. Okay. Now the second one. The second question says divisible or can be divided. You can write it divide or divisible by 3. Divisible, it's divisible, right? Now if it's divisible by 3 or 2, by 2 or 3, not and, because the question is asking you it may either be divisible by 2 or 3. It's not compulsory that the particular number may be divisible by both 2 and 3. Now we are having these numbers divisible by 2 or 3. Now starting from 1 divisible by 2, no. 2 divisible by 2, okay, 2. 3 divisible by 3, okay, 3. Now 4 divisible by 2, right, we'll write that. It's not divisible by 3, but it doesn't matter because there is or in our language, so we may consider this. If there will be that divisible by 2 and 3, then will we keep that 4? No, but in that case we will keep that 4. Okay, 4. Now 5 is divisible by 2? No. Divisible by 3? No. Okay, so 6 is divisible by 2 and 3 in both cases. 7 is divisible by 2? No. 3? No. 8 is divisible by 2. Now 9 is divisible by 2? No. But wait here, 9 is fairly divisible by 3, so we will keep that 9 here. Now 10 divisible by 3. So 1, 2, 3, 4, 5, 6, 7. Then 11 is no. It's not by 2 and it's not by 3. Now 12, yes it is. 13, no. Then 14, yes. 15 is divisible by 3. Okay, so we'll keep 15. 16, alright. Actually all the even numbers are going to be there because they are all divisible by 2. Okay. Then 17, no. 18, yes. 19, no. 20, yes. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. 13 favorable outcomes. Okay, so these are favorable outcomes. So I may write it here. Just have that language before this. Favorable outcomes. Okay, this implies that number of favorable outcome is equals to, how many we counted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. 13. Okay. So, if that's so, I am removing this first part. So, this implies that probability of occurring that event B. This is our event B. Here, event B is equals to NB by NS, and that is equals to 13, right? 13 by 20. Now, this is your answer. Second. Okay, 13 by 20 is your answer number second. Now, the third one is, prime number. Okay, so we can have that as event C. Sample space, or you can have favorable number, so we can write that like favorable outcomes. For the same, favorable outcomes will be what? Prime numbers. Now, 1, 2, 2 is a prime number, okay. 3 is a prime number, right. Prime numbers are those, they may only and only be divisible by themselves, okay. So, 2, 3, now 4, no, 5, yes, 6, no, 7, yes, 8, no, 9, no, divisible by 3 also, because, and then 10, no, 11, yes, 11 it is, 12, no, 13 it is, right, 14, no, 15, no, 16, no, 17, 17 is a prime number, 18, no, 19, 19 is a prime number. Okay, so these are favorable outcomes, and C, that will be equals to 1, 2, 3, 4, 5, 6, 7, 8. Again 1, 2, 3, 4, 5, 6, 7, 8. That will be 8. That will be 8 for sure. Now, NC equals to 8. So, probability of happening that event C will be equals to simply NC by NS. Now, NS is equals to 20. We all know about that, and NC is calculated as 8. So, that will be 4 here and 10 here. Again, that will be 2 here and 5 here. Okay. So, this is our answer number third. So, should I just rub that thing? Okay. Note it. Now, we will be talking about our last event to happen, that is the fourth. So, not divisible by 10, not divisible by 10. Event D. So, student, I have told you there is another way, easy way, tough way. Now, divisible by 10. From 1 to 20, there are only two numbers that are divisible by 10, that is first 10 itself and the second is 20. So, first 10 and 20. Now, either I can write all the numbers here and we'll just pick out 10 and 20 from there and count all the remaining numbers, and that are 18 in numbers for sure. If I remove 2 numbers from 20 numbers, that will be remaining with the 18. Okay, what I can say, not divisible by 10. Okay, so numbers that are divisible by 10 equals to 10 and 20. So, they are 2 in numbers. This implies that numbers that are not divisible by 10 equals to 20 minus 2 equals to 18 in numbers. So, that is what we are having n of d. Okay. So, n of d is this, that means probability of happening that event d is equals to nothing but nd by ns. Now, nd's values is 2 and ns is 20. That implies that that will be 1 by 10 and that will be your the answer number 4th. Okay, note this. Okay students, this is all for today. So just do practice some more questions from the AriserTalent sheet and we will meet in our next lecture. Thank you.